Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to have an exercise where we're going to evaluate or find a definite integral by using partial fractions. But interestingly, those integrals that I have in ABC are not the rational functions of polynomials directly, but by a certain or by an appropriate u substitution, you can convert each of those integrals into and integrals where the integrand is a rational function coming with top and bottom polynomials. Okay, so once you have those u substitutions, and you may start thinking from now, then you can apply the guidelines here, the decomposition of rational functions into partial fractions. So then you're going to decide if you have the fraction improper or proper. Improper means like the degree of the top is greater than or equal to the degree of the bottom, and when it's not, when it's improper, then you have to rely on to the long division. And if it is proper, you're going to try to factor the top and the bottom as much as, in fact, the bottom mostly, as much as you can. And factoring business also happens in improper case, because you will have another fraction popping up after the long division, and you're going to factor the bottom of that as well. And based on the factors, whether or not they're linear or quadratic, you have item number 3 and item number 4 applicable for that. I'll explain those in details in the video, but please have a revision before you start watching the videos. You can even pause the video right now and read the details of that, and then start the video again. All right? So we have 3 long examples. I want to get started. All right. All right, let's start with part A. We have 5 cosine x at the top, and I have sine squared plus 3 sine x minus 4 in the bottom. So the bottom looks like that it's a quadratic function of sine x. So what I plan to do is, since the derivative of sine x is cosine x, I can have a u substitution to start with, so that I can get rid of all the sines and cosines and convert this integral to something where I have a quadratic in the bottom. Okay, what I mean by that is I'm going to call u to be sine x, okay? And for that reason, du is going to be the derivative of sine x. That is cosine x dx, okay? So then this integral is equal to, since du equals cosine x dx, this is 5 du divided by u squared plus 3u minus 4. There we go. So now this integral is the integral of just 5, we can pull out, 1 over u squared plus 3u minus 4. And we're familiar with this type of integral, and this is in fact something that we can apply the partial fraction for. All we need to do is to factor the bottom out. Okay, so this is 5 du divided by, and this is going to be like the way I did earlier in earlier videos. I'm going to factor this u, and this one to be, let's see, plus 4 and minus 1, so that the cross products added, so in other words, minus u plus 4u is in fact this middle term. So that is 3u. So this way I have the right factorization, right? U plus 4, and u minus 1. So this is my way. Obviously, you can go with your way if you don't like it, or any other way is fine, as long as you can factor this quadratic out. Okay, so now I have a quadratic factored out. So now I want to use partial fractions to write 1 over u plus 4 u minus 1 as, or in the form of a1 plus u plus 4 plus b1 u minus 1. Or you can just simply go a and b. Okay? If I can manage to have this partial fraction and find a and b, I'm almost done. I'm getting closer to the end of the problem. Okay? So To achieve that, let me just clean this part here because I don't need this part anymore except that final integral. So I'm going to put it in green. Okay. So what I'm going to do is I'm going to copy this blue ink up down the solution. There we go. All right, good, awesome. So now well, before we even write 1, we should probably find a common factor here, common denominator here. So this is u minus 1, me multiplying top and the bottom for that fraction, and u plus 4 for the second fraction. We're multiplying top and the bottom so that we equate the numerators, a u minus 1, b u plus 4. I'm going to have two sample values here. One is 1. The other one is -4. Okay. If u equals 1, 1 equals 5b. That implies that b equals 1/5. Okay. And if u equals -4, 1 equals -5a, and a equals -1/5. Okay. All right, so we're almost done. We also have the 5 factor in the output, as you see, that we're going to sort of like utilize in some sense. Okay, so but let me just first erase this part here and put the AB's back here. A equals -1 1/5, and then B is just 1/5. Okay. Considering that I'm doing this for 5 over the same thing, so that means I should multiply everything by 5. So this becomes -1 and 1. Okay. So let me just put -1 and 1. So this way, I am doing the factorization or partial fraction business for not 1 over u plus 4 u minus 1, but 5 times 5 divided by u plus 4 u minus 1. Okay, so this way numbers are prettier. All right, so I don't need this part anymore because we're done with the partial fraction business all the way, right? So now we can pass the integration by integrating this for dx, and for dx. Okay. All right. I'm going to have 2 different substitutions here if you want to, which is, let's see, I'm going to have one here. Let me use a different letter here because we used u. V equals u plus 4 and w equals u minus 1, just using different letters. So that dv equals du and dw equals du, okay? So then this integral here is written as minus du over u plus not du, but dv. Okay? And this is dw over w. Okay? All right, that turns out that you have ln absolute value of v, ln absolute value of w, plus c. Okay? Putting the u and v and w back, minus ln u plus 4 plus ln absolute value u minus 1 plus c. Okay. So now I don't need this part anymore. And I'm going to do the final shot here, and I'm going to back substitute sine x here. Okay, so continuing from here, this is equal to minus ln sine x plus 4 plus ln sine x minus 1 plus c. Okay? Sine x minus 1, I'm sorry. And you can simplify this even further because you have the difference of 2 ln's. So ln a minus ln b is ln a over b. So in other words, this can be further simplified as sine x minus 1 and sine x plus 4 plus c. This is a nice property of the logarithmic functions. All right. And this is the final result. That is the value of the integral that required one u substitution in the beginning and one partial fraction and two more maybe simple u substitutions here. You cannot call it u, but let's say v and w substitutions here. Okay, so and in return we have this result, and we simplified even further by using properties of ln. All right, and I think this is the end of part A. Why don't you move to the next video to see what I'm going to do for part B? All right, bye.